I found this project PNPM, and since then my life changed for the better. I'm proud that I could solve it, but I spent hundreds of hours to make it work. But now I'm proud that it worked out.
Hello, welcome to DevTools-fm. This is a podcast about developer tools and the people who make them. I'm Andrew, and this is my co-host, Justin.
Hey, everyone. Today, we're really excited to have Zoltan joining us. So Zoltan is one of the creators and I guess the current project lead of PNPM, which is awesome. I've been using PNPM for a while. It's been my de facto, I guess, since like the Yarn 1 days, which is feels like forever ago, but I guess in relative history, it's not been that long. So we're really, truly excited to have you on. And before we jump in and talk about your work on PNPM, we'd just love to hear a little bit more about you. So would you like to tell our listeners a little bit more about yourself?
Sure. Thank you for having me. And I'm happy to hear that you love PNPM. So I'm Zoltan. I'm in my mid-30s. I have 2 kids. I was learning applied math in university. Then I joined some outsourcing company and mainly worked with .NET technologies. But I really loved Linux and open source stuff. So at my next company at Just Answer, I looked into Node.js, and I wanted to be like a popular open source contributor. So I was kind of trying to create open source stuff for a couple of years and to contribute. And then I found this project PNPM, and since then my life changed for the better. For a couple of years it was really hard because I had to combine my full-time job and open source maintenance of PNPM, but then it really helped to boost my career and to find a better job and to do what I like. So now I work on Bit Cloud, which is like a GitHub alternative, which helps you develop composable software. And at Bit, I work on dependency management, and they support me on the PNPM stuff.
That's awesome. I'm glad you landed a job that like helps support your work. This is like something we talk a lot about on the podcast is about like open source sustainability. And there's like very few that just like get independent funding to be able to like work on something full time. And most of them still end up like going the sort of like VC route or, doing what you're doing and working for someone who supports you. Cool. Let's dive into it a little bit. It's interesting to me that PNPM started as sort of like an amalgamation of a few different projects. So there's this issue where you had commented on Alexander Grill's IED project. And there's like Rico Star Cruz who was involved in this. And I don't know, y'all started collaborating and then kind of like PNPM came out of that. Can you tell us a little bit about the lore there? Like how did that all come about? And
so actually it started before me. I think the way I found PNPM was we had a huge monorepo at Just Answer. I don't know if you have heard about Just Answer. It's a Q&A website where verified experts answer your questions. So I worked at Just Answer, and we had a huge monorepo for front-end components. And the way it worked was there was like a registry in the San Francisco office. We were installing from Europe, and it was terribly slow. And also it was a really not sophisticated, I guess, monorepo structure. At that time, it was like just a directory with dozens of package folders. Every package folder had like a packages on, and there was a shell script that was running npm install in every single folder. And this wasn't super huge monorepo at that time, but still installation was taking up like 30 minutes. Yeah, and disk space usage was crazy. Like I never had free disk space on my computer. I guess I was searching for something about this, and probably that's how I found PNPM. And I started reading about it. about symlinks, about this new node modules layout, and about speed. Yeah, I think speed was the main concern. Probably I was Googling how to make install faster, and it indeed PNPM was blazingly fast. Like at that time, it was before Yarn version 1 came out, NPM was maybe more than 10 times slower than PNPM, maybe even 15. Yeah, I tested it locally and it was awesome. So 30 minutes became like 2 minutes. So it blew my mind. And also, as I mentioned earlier, I really wanted to be like an open source person because I was terrible at interviews. I don't like interviews. So I was planning to build my own like brand to make it easier. And I started to look into PNPM because even though it was really fast, it wasn't working after installation. It was like a proof of concept and a lot of stuff wasn't yet implemented. I think it was like summer 2016. And I started contributing, fixing bugs. And after like 3 months, Rico Stackruz gave me all the privileges because he didn't want to work on it. And yeah, as you mentioned IED. So that was like the project that initially implemented this symlinked idea. So IED was created by Alexander Google. And the reason it was created was because he didn't like the flat or hoisted node modules that the NPM team chose to switch to in NPM version 3. It was so long time ago that probably most of the people don't even know about this. But NPM 2 had like a nested node module structure, and it had many issues, mainly because of the long path issue on Windows. Because on Windows you have a limit to the number of in a file name, and it was like, I guess at the beginning it wasn't an issue because NPM wasn't so big, but then when you started to have like hundreds of dependencies, it quickly escalated. So they had to solve it somehow, and they came up with the flat node modules layout. And that's when this first alternatives appeared.
Yeah, the summer of 2016 must have really been like the summer of monorepos, because that's also when I got into it. It's funny because the first episode we had on DevTools-fm was talking about all of our like our choice picks for like monorepo tooling, and at that time PNPM hadn't really like scratched into my view yet. Like during that 2016 summer, I didn't actually ever discover PNPM. I went directly into Yarn, and with Yarn v1, I felt like going from NPM in a monorepo structure to Yarn v1 in a monorepo structure was like a huge gain. And we saw like that literally unlocked monorepos for us in that one project. But at the time, you said you were disappointed with the structure of Yarn and what it delivered. Can you like go into that a little bit and like how PNPM fixes what you saw wrong with Yarn?
Yeah, so I think we are a bit mixed up with the timeline, maybe because when maybe it wasn't 2016. Either me or you is wrong, because Yarn came out 6 months, approximately half a year after I started working on PNPM. So it was already in development when I found PNPM, but it wasn't like publicly now, nobody knew about it. Yeah, and actually I was terrified when Yarn became public, because I spent really a lot of time on PNPM, half a year, and Yarn really blew up in a few days. It got huge traction in the community. I thought PNPM is over. I got a little bit depressed. Then I think Yarn was still slower than PNPM. It was a lot faster than NPM, but still slower than PNPM. Probably more stable than PNPM. But because of the speed and because of the different layout, I kept working on PNPM even after Yarn came out. Sorry, what was the question about monorepos?
Yeah, I was asking about like how you were disappointed with Yarn. Almost a little bit of a leading question because with Yarn v1, while it did improve upon NPM structure, it didn't have like the cache methodology that PNPM and Yarn 2 went with. I feel like the real aha moment was for me was like, do I go to Barry or do I go to PNPM? And PNPM was like the way for me.
I think maybe I was disappointed because they chose the flat node modules.
Yeah, I think it's amazing that you like pushed through that moment and you're like, you know what, no, I'm going to double down and I'm going to build this. And then after all these years, that was whether Yarn came, I guess, 2017 or whenever it came out. That's still been, it's been quite a while now. And just to be like, to validate your work, I don't know anybody who uses Yarn personally, unless it is like a legacy Yarn 1. And there are still some folks that I know who use like NPM just because it's like there and the default when they're installing Node. But like most everybody else is like PNPM, and it's like almost become table stakes for Node. And I just think that like you've done a lot of work over the years to make that happen, and that's a great job. Looking back on that, it took y'all a while to reach version 1.0. It seemed like it was like about a 2-year effort. It was like a lot of push. And you'd sort of wrote about like how getting the symlinked node module structure to work was like a particular challenge. So like what was the journey into that like symlink structure, or like rethinking how node modules are structured, and what were the big challenges there?
So I think the biggest challenge was resolving peer dependencies, because when a dependency has a peer dependency, you might get duplications of that package, of that dependency, because this peer dependency might be resolved from different versions of that peer dependency at different places of the dependency graph. And if you open the .pnpm directory in your node modules, you can see that it's a flat structure where every directory is the name of a package and the version of the package. However, if a package relies on peer dependencies, you'll see also like a list of the peer dependencies there. So if a dependency has peer dependencies, it might have like duplicates, which is actually not good. You need to try to reduce this, but we need to support it. And I'm not sure the first version worked completely correctly with peer dependencies, because somehow every year peer dependencies become more complex. And I think the first time PNPM did it fully correctly was version 9. And the reason this was so hard, is because peer dependencies can have peer dependencies of their own. So it's a recursive story. And basically we need to build a peer dependency graph and then hash this graph and use it as the directory name inside .pnpm. And also, the peer dependencies can be also used inside sub-dependencies of these dependencies. So it's very complex.
Yeah, I've definitely hit upon that complexity myself. Peer dependencies, I'd say no matter what package manager I've used, have been like a tough thing to deal with. But the way PNPM approaches it, at least, is it feels like one of the more sane ways, where you can actually see like how the peers have resolved very easily and see the duplicates very easily. Whereas if it's not all that flat, it's almost impossible to debug those issues.
Yeah, I think what we lack is ways to debug your graph. Like after you installed it, have some tooling to help you figure out what is happening inside node modules. Because right now you can run PNPM list, but it's very cluttered. Or you can manually try to read your log file, but it's hard. Actually, I've worked now on a feature that might help with this.
Since you've thought about it a lot, do you think peer dependencies were a mistake? Do you think they're necessary? Is it like a bit of complexity we've put in our own paths and just trip over constantly?
I think probably they are needed. I don't know if we could re-architect it without peer dependencies. Maybe it would be possible. I don't think about it much because it's so baked into the ecosystems that it would be impossible to change. And actually the challenge was, now that I'm over it, I'm proud that I could solve it. But like I spent hundreds of hours to make it work. But now I'm proud that it worked out. Yeah. Maybe all these recursive peer dependencies, maybe what we could do is limit it a bit, just to, because probably sometimes they are not needed, but people still use them. I don't understand why peer dependencies should have peer dependencies of their own. I'm not sure. And also why some packages have like 10 or more peer dependencies. So yeah.
Yeah, there's like, I feel like people either don't use them at all or they overuse them. It's like people discover them and you like get in these projects and there's so many.
And also they are very hard because you basically publish a range and then it's complete chaos.
Yeah, for sure. Let's switch gears a little bit and kind of talk about some of the in-depth implementation of PNPM. You talked about the difference that PNPM does in how it structures the node modules. So under the hood, you'll have this content addressable storage model. So like practically, like how does that work? So you have this like .pnpm directory and the packages under there, and like where are the actual links and like how does that resolve?
So we basically have two layers. The .pnpm folder is something that we call the virtual store. Someone also suggested to name it isolated store. I'm still thinking about if it's a good idea to rename it. Virtual was chosen because it uses symlinks. So inside this directory, as I mentioned, every version of every dependency has its own isolated directory. And if you open up this directory, every single directory will have node modules subdirectory. And inside that directory, you'll have the directory for that package with like real files, and all the other files in that node modules directory will be symlinks to other directories in the .pnpm folder. So this way you get nesting, but in a controlled way. So you won't have long path issues. The content addressable store is not inside .pnpm. It's in a central location on the disk. And these are files of all like extracted dependencies. And these files are stored by their content checksum. For instance, if you have two versions of Lodash installed on your system, probably most of the files will be the same in the two versions. So in this case, the similar files will be stored one time on the disk, and differences will be stored separately. This is very effective and is used by many tools in programming. And the way it works is that dependencies inside your projects.pnpm are pointing to this central location on the disk, to the content addressable store. And they are pointing with hard links. Hard links, or if the file system supports copy on write, then actually ref links. Because hard links have a disadvantage. If you have two projects and both projects use Lodash, let's say you want to debug something, you go to your node modules and you make a change in your dependency in Lodash. So you'll make this change in project one, but in it will be changed in project 2 as well, because it's a hard link. So it's the same file in every place. We actually revalidate the files when you install again. So we will change it back to its initial state. But the better approach is to use these ref links, because with the ref link, when you make the change, the file system automatically copies the file and saves the modified version in your node modules. So the central content addressable store is not changed, and you get the modification only in that single place. That's, I guess, it.
You had also recently introduced like an experimental feature of having a global virtual store, a parallel concept to the content addressable store, right? So from what I understand, instead of that like .pnpm file that's like local to your node modules in your project, it's like a global sort of reference where everything is linked. What was the impetus for adding that?
Yeah, this was actually my dream from the very beginning. And actually, in the early versions of PNPM, I was using it, but it was only working because we didn't have a log file, and I could go crazy. So this feature is called the Global Virtual Store. You can try it out. There's a setting to enable it. What it does is basically it moves out this .pnpm directory from your node modules to a central shared location on the disk. But because it's moved out, it becomes more complex, because in scope of a project, every dependency can have only one set of sub dependencies. So if you have like webpack 1.0 installed, and it has minimatch with the range of 1, in your project it will be webpack will be always resolved to one version of minimatch. But in another project on the same computer, you might have run executed install later, and now you will have webpack with minimatch version 1.2.0. So locally it's not an issue, but if you move out this store to a central location, you need to have two webpacks now. One webpack with minimatch 1.0 and another one with minimatch 1.2.0. So if you check this global virtual store, you will see that instead of having directories with just package names and package versions, we will have directories with package names, package versions, and a long ugly hash. And this hash is the hash calculated from the dependency graph of that package. This is somewhat similar to what we do with peer dependencies, but now it's done for every type of dependency, not just for peer dependencies. And this, I really hope that we'll be able to make this like the default at some point, because it makes local installation super fast. On CI, it doesn't really make a difference, because on CI you have a dedicated empty machine, so you won't have this hot cache in a central virtual store. But locally, when you have several projects in your source folder, there's a big chance that most of the dependencies were already installed by some other project. So instead of all these file system operations to create this .pnpm folder from scratch, you need just to create a few symlinks to this central directory, and just for the direct dependencies of your project.
Cool.
So, yeah.
Moving on to some other things, PNPM is really packed with a bunch of really nice developer-centric features. Like we've already covered a few of them. Workspaces is really nice. I love that it's consumed some of the monorepo workflow, so we don't have to depend on third-party tools to solve that. Catalogs is also, I love catalogs. it makes managing monorepo dependencies so much easier. But you recently introduced a new feature called config dependencies. Could you walk us through what those are and what they solve?
Yeah, config dependencies. I was inspired by Bit for config dependencies, because in Bit we have like components, and every component has an environment component, which contains all the configuration for this component. And it's really easy to share your configuration between your components. When you work with Git repositories, it's really hard to do. You basically have to copy paste a lot of dot files. So I thought it's a really cool idea, and maybe we could make it simpler for PNPM users to share the PNPM settings between repositories. At least the PNPM config, you can have a better solution for it than copying .pnpm files. And so basically config dependencies are a new type of dependency with a lot of limitations. Like these dependencies, they cannot have dependencies of their own, and they cannot have post-install scripts. And these limitations are necessary to make the installation of these packages really fast, because they are installed before the regular install at the very start of the CLI execution. And because it's so early on in the process, you can use it as a plugin for PNPM. You can change the configuration object of PNPM from these config dependencies. For instance, if your organization has some specific settings that you use for PNPM, because by default, PNPM is somewhat permissive, but there are some settings that you can use to make it more strict. So if you want to do that, it's really easy to do with this config dependency. Also, I think you know that in version 10 we start to block the execution of scripts by default. So it's really convenient to have a config dependency with a list of trusted dependencies that you trust in your organization. Or even catalogs. You mentioned catalogs. So you can have a config dependency with all the catalogs and even share them between repositories.
Yeah, that feature and being able to share patches just seem like a huge win for people, especially the patches one. Like I personally work on a design system in a separate repo from the rest of the code at the company I work at. So if we want to ship patches to some of our dependencies, it's this long process of trying to shuffle code around and making sure it's in sync. But with this feature, that's a thing of the past.
Yeah, you can be very creative with them. Actually, sometimes I use it for stuff that I didn't think about it when I was coming up with the config, but it's so powerful that it makes it possible to change PNPM without changes to PNPM.
Yeah, it's really awesome. I do want to give a shout out also to just the patch feature. So our first guest on this podcast was David Sheldrick, who wrote Patch Package. He was an old colleague of mine at Artsy. And so Patch Package, fantastic project, but having it built into PNPM has also been just really cool, because it's one of those things where it's, for better or worse, you get in these situations where something doesn't work as you expect, and your options are either fork it or figure out some other way to fix it. And the patch command is so great. And the little DX around the patch feature too is really good. It's being able to just create a new patch and have it open in an editor, do all the stuff, and have the commit command. I don't know. It's a really good experience, and I really appreciate it.
The funny thing is that I think we use a patched version of patch package in PNPM.
Oh, that's amazing. It's very meta. Yeah, that's great. So you just mentioned in version 10 of PNPM, you disabled lifecycle scripts by default. So it's the post install script, for example. Why was that change necessary? What was the thinking behind that?
You might have heard about NX, the NX incident recently. So this was actually not the first incident of this type. There were, I lost count how many. And we had for years people asking for ways to limit script execution. I was opposed to it because I was thinking that why does it matter if a package is compromised? It can still run its code when you run your tests or just start your application. But then I got some counter arguments, and I don't know, I'm sure I remember all of them. But for instance, they said, what if a dependency is not executed in the code path that you use locally? So there is actually some security in it. It won't solve all the issues. So it's just one way to reduce the attack vector. It's not a silver bullet, but it's better than nothing. It was a really painful change. A lot of people were mad, probably still mad, but also a lot of people were happy about it. And we were not the first ones to do it because Ban already did it. However, there's a catch. Ban actually ships like a list of trusted packages. I think it's like the 500 most popular packages. And NX is actually in that list.
Oh, no.
Yeah. So I was making a poll if people want to have the same in PNPM, if they want to PNPM to trust these 500 packages. And the poll was still running when the NX issue came out. So now I'm really not sure if it's a good idea. Yeah, there's. I was considering maybe to make it more strict. So the package also has to have provenance enabled. This is a new feature from the NPM registry and GitHub that you can basically disallow publishing using auth tokens. And basically this package that you enable provenance on and you disable auth token publishing, it can only be published from a GitHub repository that you link up with your NPM package. And on the GitHub side, you can require an approval to actually run the release action. So this is more secure. But I was thinking just today that maybe they have to also require one-time passwords on the approval on GitHub. But looks, yeah, that's it.
Yeah, there's probably so many different packages that are just like available to be hacked right now just through their CI/CD processes. I didn't know about this provenance feature, but it does seem like a good step to try to fix that. But keeping keys secure is a hard game, and it does not jive well with automated releases.
Yeah, I think we will work a lot on features to try to mitigate this. There's just today that these popular packages were taken over, used by billions of like packages that have billions of requests of downloads per week.
Yeah, the one you're talking about is the debug and chalk packages,
Yeah.
right? The blast radius of that one is so immeasurably large.
Yeah, so for that one, we got suggestion to add the feature to PM to tell PM to have a cooldown for a released package. Like, for instance, a released package has to be 3 days old to be installed. So this way, because these vulnerabilities, they are detected really fast now. I think that today's issue was detected in 5 minutes. The NX issue was also discovered in 1 hour. So there will be a cooldown. Less people will install the affected packages before they get removed from the registry.
Okay, so you've had the Node ecosystem is a very broad ecosystem. And when you're making Node packages, they might be installed in a multitude of places. We got Electron apps, we got React Native apps. There's some people store code on an NPM that is never intended to even be installed on a website. So, what are some of the most common compatibility issues that you've found trying to get those projects to work, and how do you try to address them?
To be honest, I think in the past there were two big issues. One with the phantom dependencies, the second one with symlink usage inside node modules. I think with symlinks almost everything works by now. Maybe only Electron has issues with symlinks. And there are some workarounds, I think, with how it's called, the Metro. What is it, a bundler for Electron or what?
Yeah, Facebook's bundler, Metro.
Yeah. So I think there's a workaround for symlinks, but I think the easiest solution is to just make PNPM install the regular hoisted node modules without symlinks. So actually, PNPM uses a library maintained by Yarn for hoisting. So we use the same algorithm for hoisting as Yarn. And if you use PNPM with some project that doesn't work with hoisted symlinked node modules, or if the project heavily relies on phantom dependencies, you can set the node linker setting to hoisted, and it will work because it's basically the same as what NPM creates, or Yarn with the hoisted layout. The other issue, the phantom dependencies, we had in initial versions of PNPM, we had a lot of these issues, and it was really hard to fix these issues because some maintainers of some projects, they believe that it's fine to use. So yeah, actually, I didn't explain what phantom dependencies are. So when a project uses npm, which creates a flat node modules, your code can basically import any dependencies that is in the root of node modules. So even if it's a sub dependency, your code will work because Node.js doesn't care about what is in package.json dependencies. It just cares what is inside node modules. So we call this a phantom dependency. So if you have Webpack in your dependencies and Webpack has minimatch in its sub dependencies, your code can import minimatch and it will work. And it will work even when your project will be installed by npm, because the target node modules, again, everything will be flat. But with PNPM, as I mentioned earlier, inside .pnpm, every dependency is isolated in its own subdirectory. And inside this subdirectory, it's not a flat node modules. It's a limited node modules that only contains the direct dependencies of every package. So if you are importing Minimatch in your package and someone installs your package with PNPM, it will break with Node.js error during runtime because Node.js will not be able to resolve Minimatch. But yeah, it was, as I mentioned, not all maintainers were willing to fix these issues. So we had no choice, but we had to add some workarounds to fix it on our side, to add some workarounds on our side. And what we did was basically we created a node modules directory inside the root of .pnpm. We create like a hoisted node module structure there. So your code in your project cannot import these sub-dependencies, but your dependencies can actually import these phantom dependencies. Because when Node.js looks up for packages, it looks up in every parent directory. So it will look up inside the .pnpm node modules. So this works by default. You can actually make it more strict by turning off this hoisted node modules. And if in some edge cases, some tools actually don't work even with this, I don't know an example of such tools now. But in this case, you can either use the completely hoisted NPM-like node modules with node linker hoisted, or you can use the shamefully hoist setting. And what it does, it is basically moves up this .pnpm node modules to the root of your modules. So even your application code will be able to import phantom dependencies.
It's a great name for a setting.
Yeah.
It's like the React internal thing. If you use this, you will be fired.
Yeah, I think I was inspired by React or some other tool. Yeah, but I took it from somewhere.
Cool. So we're getting ready to wrap up. And as we do, we always like to ask our guests a forward-facing question. So you've been working on PNPM in the package management space for a while now. And the Node and JavaScript ecosystem is also changing. There are a lot of new runtimes. We're deploying JavaScript to a lot of weird new environments. There's very slow movement inside of NPM, but there are a lot of new registries coming out. So when you look forward to the next few years, especially as you're thinking about like your work on PNPM, how do you think the package and just JavaScript runtime space is going to change? And how do you think that'll affect your work?
How it will change? I would expect maybe some more registry alternatives, because all the money is on the registry side. Nobody pays for the client. So I would expect maybe, especially those that are like have companies behind the clients, maybe they will have some motivation to create registries. Also, maybe some companies that run code, because they could make their CI faster with a custom registry, and that takes over some of the logic. I have a lot of things I would love to try out. Yeah, and I think in general, companies that have CI/CD of their own, they might come up with some maybe even appropriate like closed source solutions to make installation faster, sub-second fast. On my side, I have a like Gym to make PNPM work for a different language maybe, or for a different runtime. So I have actually added this feature to PNPM to be able to manage Node.js versions. So this is a step into that direction. And I added a way to manage Dino and ban. So it would be, I think it would be great to be able to use PNPM for Dino projects, or even to something like, I don't know, Python. Although I know Python now has a really great package manager, so the competition there is really strong. So maybe some other language, but I would be open, even for installing Vim plugins. Because when
maybe you're just the UV of the node space. You know?
But I'm even open to rewriting it to Rust if it makes it faster. We did some experimenting with that, but we couldn't figure it out how to make it fast, because I think there's more possibilities on the registry side currently.
Interesting. That wraps it up for our questions. Thanks for coming on. This was a really interesting dive into all things PNPM. And I know both me and Justin have used PNPM just like relentlessly and are ever thankful for the work that you do in the community that you support. So thanks for coming on and talking about it.
Thank you for having me.
Yeah, thanks so much, Zoltan. Your work is fantastic, and I hope you're able to continue to enjoy it going forward. I know that open source is often, I think, less and challenging.
Yeah, it's very competitive. Yeah, I think I already achieved something that I can be proud of, even if it fails at some point. But I hope it won't fail. Like, I know there are projects that live for decades. I hope PNPM will be such project. Vim exists for 40 years? I don't know. It would be cool.
Absolutely.